Hi everyone again. As you probably already know, I will be giving a presentation about load testing for small projects. So previous two presentations were quite similar topics: flaky tests, browser UI automation. I'm going to go a slightly different direction and talking about load tests. First of all, I'll start with some facts about me. As I said, I've completed studies in IT fields. I have my master's degree from the University of Edinburgh, finished the bachelor's in Latvia, went to study in the UK for that 1 year. I started my career as a quality assurance engineer at TestDevLab. I worked on various projects there, and at one point I switched my focus more to testing WebRTC-based solutions, which slowly led into the next venture, which is still ongoing. And I started to work on Loadero, pretty much been there ever since. And that also ties into the topic of what I'm talking about today, because Loadero is a web application testing solution. So we're testing web applications using UI automation. And the unique thing about our tool is that we scale a single test into thousands of participants. We have actually launched Selenium tests on the same website with 80,000 concurrent sessions. And while my main responsibilities are leading engineering team, I'm still participating in some testing activities for other clients, so I can gain some real-world experience on load testing as well as help our customers. And that's where my experience comes from and why I'm talking here about load testing tips. So first of all, before even getting into details about load testing itself, I wanted to talk about what really is load testing itself. And the simple definition actually is that load testing is finding out how the application behaves under stress. And that stress is the expected level of users visiting the website. So if concurrent active users for a website norm at peak hours is, say, 500 users, then a load test would test the new application's version with those 500 users. Why load testing is needed? Because it can often happen that system just lacks resources. It's using a lot of CPU, it's using a lot of RAM. It could be using a lot of files and reaching open file limits. Different hardware-related reasons. It can also be good to check that the scaling that's calculated on paper matches the actual scaling, how it happens in real life. In my experience, I've seen it go both ways. I've seen that an application is struggling with a server that has 1 GB of RAM, but then when we upgrade it to a bigger instance, it's using 900 megabytes and running just fine. And usually what we've seen is that it boils down to the system just not being able to spike above that 1 GB if needed, and it's just using too many resources to manage that memory. And we've seen it go the other way around as well, that if 100 users can run on a system that has 1 GB, then a system with 2 GB might handle only 180 users, for example. it very much depends on the application itself, what the application is doing. And also, another good reason to do load testing is to catch some bugs that are only possible in high concurrency. That could be, for example, memory address violations. Even before I started to work at Loadero, on another project, we saw an actual bug that only happened on production loads because memory sharing was not handled properly, and on staging environments, it was just not possible to catch it because the chances of that happening were so slim that it happened only once every couple of days in production. But yeah, when we did a load test on the system, it was possible to catch that bug with a higher frequency, especially when we went over the user limit of the production. What I think about load testing is that load testing is and should be a part of the whole testing process, the same way as the testing process is part of product development. It's not so popular right now, but some time ago, and sometimes in smaller projects, managers don't think about testing as much. They only think about development, and sometimes they push out a release without really testing it. And the same thing is about actually load testing. Once testing process is introduced in the product development process, it's also good to think about load testing the application. That's just another reason why the application can fail. And there are several points in application's lifetime when it makes sense to do load testing. Yeah, so I don't think that load testing is only black and white, only okay or not okay. In practice, what I see is that load testing is often something in between those states. Obviously, the perfect scenario would be that no issues are found during load testing, but most often there still are some issues. There still are some percentage of just some Nginx errors or Amazon errors that pop out under high load. But the development team, the management team, they decide that this percentage is acceptable under this load, and the application is moving forward. This is just one example. There can be many different things, and it might be considered that it's not okay to push further, but it's rarely actually goes to a complete crash, completely unavailable website. Generally also because once we see that the application is starting to struggle, the load test is usually stopped. Yeah, and quite often the first findings are not what we are actually looking for in the load test. That doesn't mean that these findings are bad. These findings could be good, but load testing is usually full of surprises because testing for some functional regressions, developers are doing that on their local machines before pushing. Obviously not everything, but at least on sanity level. Load testing on a local machine simply isn't really feasible. And even if it's done to the scale of the local machine, on the production scale, it's a whole different thing. And yeah, for example, one common thing that can be found when starting to load test, especially if it's a one-off load test, is, for example, rate limiters. There are just so many things to set up for a load test that a simple thing as a rate limiter can be forgotten and the system starts to reject the requests because one IP address is spamming too much. And yeah, that's often just a good side benefit, seeing that the rate limiter works, but it interacts with the load test. And finally, a thing to note is that load testing is not stress testing, which is something that people very often confuse. Stress testing is already going beyond the normal system load and trying to find the breaking point. So if an application passes load test with normal expected usage of 10,000 users, the managers might decide to go further and find out how many users the application can withstand. And that's already stress testing. So we'll be going on some increments over 10,000 to find the magic number that actually breaks down the application. So it could be 14,000, it could be 17,000, it could be 10,500. That's the point of stress testing. And load testing, in a sense, is slightly simpler because we don't need to find the upper limit, but we're testing the system under the load that is expected to be. Yeah, and the next thing we're going to talk about is how to do load testing in general. While most of these steps seem to apply to bigger applications, large-scale load tests, big teams, that's not necessarily true. Most of these steps perfectly apply to any application that load testing is being done for. So first of all, the first thing to start with any load testing procedure is what results are we actually looking for. So it can be very different reasonings for doing load tests, but it's important to understand what results we are looking for, so the best approach can be selected at that point. You could be looking for API latencies. You could be checking the user experience when system is under load. You could also be checking third-party integrations. Sometimes external vendors don't perform as good as they do, as you would want them to. And yeah, as I mentioned in the beginning, hardware capabilities can also be load tested. So it's important to choose the correct approach because it impacts how expensive the tests will be and how do you look at the metrics. For example, usually the easiest way to do load tests is to do API load tests, but in that case you need to have a way to translate those API load test results into the results that you're looking for. So if you test with 1,000 requests per second, how many users is that in reality? Because if it doesn't necessarily translate to 1 request per second means 1 user. The users could be idle in the application for a long time, or they could be doing a task that issues more than 1 request per second. Therefore, sometimes it needs to have other means of testing the application. It's not sufficient to run API load tests. Sometimes there are other integrations that require use of other tools, not API testing tools. So, for example, to test third-party integrations, you wouldn't really normally use API load testing tools directly to their APIs. That could possibly lead to some bad consequences with the vendor. The next step usually is choosing the approach, how the test will be done. That means what tool will be used depending on the choices made previously, how often will the tests be run, and what will be the ramp-up strategy for the tests. So I think choosing the tool is fairly straightforward. And I think often what people are afraid to say out loud is that it makes sense to choose a tool you're familiar with. But obviously each tool has its own benefits, but I think in practice, people just choose the tool they're familiar with. If you're familiar with 5 tools, great, you have a great arsenal of tools. Choosing how often you will run your load tests is an important decision, because if you plan to do a one-off load test, then you don't need to think about how usable is this tool in long term, how maintainable are the tests, and maybe how expensive are the tests. You just do the test, you forget about it. But if you plan to do frequent load tests, for example, at the end of every sprint doing a load test on the new version, then you must think about how maintainable are these load tests, how much will they cost every month, and maybe at that point it's worth investing more human hours into development instead of investing money in a tool. And finally, ramp-up strategy, which is one of the main things you have to think about load test as an engineer. So usually what we do for any load test, we always start small. So if a person comes to us and says that I want to test 1,000 requests per second, we will almost never start with 1,000 requests per second, just because that's the limit the user actually, the client hopes his application will sustain. I'm talking here more about one-off load tests. If they are routine load tests, then most likely it's not needed, and you can really start with 1,000 requests per second. But in practice, we'll start with 100 requests per second and see what happens then. Maybe you already see some issues with the same request rate limiting that I mentioned before. It's worth catching these issues, fixing them early on with smaller loads instead of going big from the start and just seeing everything break down and not being able to understand what exactly happened. So always start small, go with some increments that make sense, depending on your target load, depending on known characteristics of the system. Don't be afraid to pause the tests midway, and that applies both to a specific test run. If a system is breaking down, there's no point in running the test for another 10 minutes. The system has broken down. And also in between those steps. So if you see problems with 200 requests per second, there's no point really going to 400. You're just going to see more problems, more requests failing. So at that point, it's worth saying that, okay, that's it for today. Let's get back to the drawing board. Let's fix the issues that we have and continue next week or whenever. And the final thing about ramp-up strategy is to be aware of how quickly the requests start flowing to the system. Often, the start of a new session requires slightly more resources than an ongoing session. So, for example, those could be login requests plus user account info request plus a list of news plus list of comments, likes, whatever. So when an application is open, there could be 10 different requests requesting different information for that user's session. And when the user is continuing to browse the app, the requests are distributed more over time. So what this means is that the system might be able to sustain 1,000 concurrent users, but it might not be able to sustain 1,000 users joining at the same time, because throughout the usage, those 1,000 users maybe create 200 requests per second. That's really high even. But when they are joining, they might create 10,000 requests per second, and that's the difference is enormous there. So with high user numbers, it's really worth thinking about how those users are joining the test. So maybe the users will join slowly over a period of 2 minutes, maybe 10 minutes. Maybe they join in batches. There are a lot of different options for simulating this part. But it's really worth taking into account, because if the system crashes at the beginning, it might not be able to recover immediately after that happens. Some systems will recover. I've seen that happen. The system to crash at the very beginning of the test, but to recover after a minute or two. But that will not always be the case, because new requests are still coming in. Yeah, the next obvious step is to prepare a load test scenario. So first of all, figuring out what will actually happen in the load test. That depends on what you're trying to achieve. So if you're trying to simulate real users, you might want to design the load test based on what the users are doing, what's the known behavior. If you're trying to test a specific part of application, for example, the search functionality, then you only need to target that part. An important step that for us always takes more time than it should is preparing credentials. As I said, Loadero is a web-based testing tool, so we're testing web-based applications. And we often have problems with credentials, meaning that we can't just reuse a single email password combination, because when the user logs in, he does some actions. For example, likes a page. The page stays liked for all the other sessions that's using the same credentials. So we often need to have different credentials for every user. And this can be really problematic based on what's the approach for the load test. Based on what's the approach for load test, also based on the characteristics of the application, because sometimes it won't be possible to create fake accounts. Sometimes the client might want you to test sign up, but the sign up requires email validations. If you can, obviously mock it, as suggested in one of the previous talks. But if you can't mock it, if it's a hard-coded system, then that can be a big issue. So this is something that's worth thinking about from the very start of the testing process. Finally, obviously, implement the scenario in the chosen tool and test on small scale. Test on 5 users, test on 10 users, 510 RPS, whatever, depending on the application. But do run the small scale tests. That will help you catch some of the issues. As I mentioned, for example, data persistence after different sessions. Really depends on the application itself as well. The next step is preparing the environment. Depends on what's the project structure, but this could be done by you, this could be done by the ops team. Ideally, there is a separate isolated environment that is as close as production as possible. That's the ideal scenario. You can run the tests there, not mess up the production, obviously. But sometimes you do have to run on production because it's just not possible really to set up. I've been there. Hopefully, usually it goes normally. In my experience, thankfully it has. But in that case, we were running the load tests at 3 a.m., 4 a.m. when the usage on the service was at its low point during the night. And we had ops team ready, also participating in the test. So if anything happened to production environment, they would be able to restore it as quickly as possible to minimize any downtime. Yeah, so if possible, do set up a production clone. That's often the ideal scenario. Even if it's possible to clone the data, even better. So as for scheduling the tests, load tests are not regression tests that can be run anytime, especially if it's not a separate environment. So scheduling the tests is quite important as other people will get impacted by the load tests. So it's important to synchronize with all the possible stakeholders. UI engineers might want to join as testers and see what's going on. Developers might want to be aware. So, for example, if you're testing on staging, the developers don't push some weird changes that, for example, limit the possibility to run the load test. They might also want to participate in the testing or do some monitoring of their own. Ops team will obviously want to do some monitoring. You might want them to be on call as well if anything bad happens. So if an environment crashes, you want to have somebody that can restore the environment as soon as possible. One of the interesting stakeholders that need to be notified usually is marketing team. As we were running our load tests through the front-end application, the load tests trigger a lot of Google Analytics. Almost any website does have them, and the load tests do generate spikes in analytics because suddenly, instead of 1,000 visitors in the night, you had 50,000 visitors. So the marketing team might want to be notified. They might want to discuss possible ways that you can avoid those spikes in analytics so that the data is not messed up. Depends on the service again. Maybe it's possible to disable the analytics. We've done load tests with setting up custom user agent headers so that the marketing team filters out those user agent headers in their analytics reports and flags them as coming from tests and doesn't include them in statistics. But if they're not warned before, they might be quite unhappy because the analytics are messed up and their percentages all show off. And obviously, if you're dealing with any third-party vendors and load testing systems that impact them, do check with them if it's okay to run such load tests. Do estimations on what are the damage to them, how much requests are you going to send them, and if possible, contact them and make sure that it's okay to do these load tests. Sometimes that's specifically what people want to load test, because they know that their application will handle the load, but they're not sure about some vendor. So they want to do load tests on these vendors. And while for the client, it's very good to know that the vendor can't hold the load and crashed before reaching their production loads, the vendor's environment still crashed. So it's important to let them know that you're planning to do such a thing. And yeah, that's pretty much all that is on my checklist for preparing a load test. And that's when we start to run the tests. No matter what the chosen approach, what I always do is I always monitor the application manually. So it's either me, it's either another engineer, the development team, QAs, whatever, but somebody is always monitoring the actual application and how it's behaving. Because no matter what, load tests are being run by automated users. So they will only be able to catch some issues that affect them. For example, you might see a lot of console errors in browser, but a load test will not be able to catch those because it just doesn't look in the browser console. You might be able to see some images maybe not loading properly due to load. That's also something that the automated load test might not be able to catch. Basically, you're giving subjective evaluation of how the load behaves. And yes, quite obviously, do monitor everything that you can monitor. Monitor from cloud platform provider, monitor from the servers, monitor everything you can, because it's always better to get as much metrics as possible early on, rather than find out that you forgot to monitor database load and not know how the database behaved, because turns out that database might be the bottleneck. And yeah, as I kind of mentioned, usually it doesn't go according to plan. So usually after the first round of load tests, there's some pause and we're running the load tests again. Almost never in my experience, we have completed load testing in the expected time period, at least what the customer expects. It usually takes a while and then it's a repeated load test. So yeah, this period in between the tests is good time to address issues spotted in the test script, some concurrency bugs in the test script, as well as for the developers to address issues in the application. Yeah, and then going on to some tips, tricks, facts, questions about load testing for smaller projects. And the first is why it's even worth testing for load on small projects. If the application has 100 daily users, what's the point to do any load testing? First of all, consider what the application is doing. If it's a static website for a photographer, then maybe it's not really worth load testing that. It's just loading static files. So even under 1,000 users, if they're browsing a single page application, that's all happening on the browser side, it's all static, there's no backend. Okay, at that point, maybe not. But if it's, for example, a video calling application, the difference between 10 and 20 users can be quite significant, especially, for example, in WebRTC, it's quite often to see a peer-to-peer call. That means that every participant on the call is sending his video to every other participant. So If there are 5 people in the call, that means you have 4 outgoing streams. If there are 10, you have 9 outgoing streams. And if that all goes to a centralized media server, the number of streams grows exponentially. So even on these small projects, it's worth doing load tests, but you have to know the application. So it could be a media provider that runs 1,000 calls concurrently, but all of those calls are one-to-one calls, and you do one 5-person call, and the application load suddenly grows exponentially. Another reason to think about load tests in small projects is that it's easy to forget about them later on. You might start out with 100 daily visitors and just be happy about metrics growing, seeing 500 daily visitors, 1,000 daily visitors. But you might get so overwhelmed with counting how many visitors there are that you forget that you postponed load tests for this reason, that you had so little users. It's important to think about them from early on, and if you're not doing them early on, then keep in mind that you will have to do them, and it might be worth starting to plan for them early on. Another reason is that the scale of the application is small. So 100 users extra opening up Google search is unnoticeable on Google's side, but 100 users suddenly opening a small application that's seeing 100 users daily, that's a huge spike for that project. So pretty much think about spike protection. That spike might not be large. It doesn't need to be large, but it's worth testing out some reasonable number of participants suddenly joining the application to see how it behaves on a sudden spike. Another good reason, think about what's the cost of not testing. Often we think about load tests as they are expensive, they might not be worth it, maybe we won't need them, but all in all, that they're expensive, it's just money. What will be the cost of not testing? So what's the cost of restoring the system on a Saturday? Imagine you have, for example, an e-commerce store and your shipping system crashes under load. People still keep buying t-shirts, but your shipping system hasn't processed them because it's crashed. So now you have 500 orders that you need to manually process because you didn't think about load testing earlier on. So doing load tests is a good way to protect against these things. On bigger projects, these issues most likely will be resolved by a dedicated team, maybe doing some scripting, maybe just with manual power, but on small projects, especially if that's your personal project, you might be the one responsible for fixing all the problems. Yeah, and another cost can be reputation hit, not only for big projects, but also for small projects. If you have hundreds reliable customers, what will be their user experience in case of a crash? Losing 1 out of 100 customers, that's losing 1% of your customer base. Losing 1 out of 1,000 customers, that's a smaller percentage. So it's also worth thinking about from that perspective. And yeah, small projects doesn't necessarily mean that they don't draw attention. You might start selling super cool t-shirts that everybody just wants, and that just draws attention you didn't expect. So if you had thought about load testing, that's a good thing. And yeah, coming to an end of the presentation, there are other use cases in small projects, in small scales, when normal automation tools don't make sense, but load testing tools do make sense. For example, when planning regular load testing. So if you're a small project, but you're thinking about load testing and you're thinking about doing load testing at the end of every sprint, it's worth thinking about load testing tools that will be able to support the scale that you're aiming for. Everybody's aiming to earn millions, but in that case, maybe it's worth spending a few days extra at the beginning to plan load tests, to choose the correct tool, so that they will work on scale instead of redoing them once you hit 1,000 users. Another thing is that choosing the tool is quite important because it will depend on how quickly you can do the tests. For example, simulating 100 users, it could be done, for example, with doing a script. So you could do a shell script, Python, Java, whatever, that simulates 100 connections. It will cost you nothing apart from your development time. But at the same time, many of the tools, they do work fine with 100 users. Even if load testing tools are created to work with thousands of users or thousands of requests per second, they will work perfectly fine with small numbers. And it might be cheaper and faster to use a load testing tool that's even meant for big scale load tests to do small scale load tests. The results will be more reliable. It will be faster to get the results, and you won't be spending your own time so much on maintaining the load test tool, and then later in the process just switching out the load testing tool because your JavaScript can't keep up with the demand. Another often use case, specifically often seen in WebRTC use cases, is running load test of 10 users. So quite often, especially in the past year, we've seen demand in testing for video applications, and they're often not looking to test with thousands of users, but they're looking to test with 10 or maybe 50 users and seeing how the video call behaves under that load. So initially, the QA teams often start with manually joining to the room with 10 users, but soon enough, that becomes quite difficult to always get 10 people to join the room to test one thing, maybe test one fix. So a load testing tool at this point can also be a good option to simulate those other participants that you need to test your fix. And yeah, another trend that I've seen in my experience is joining functional and load test scenarios. So that is, people are generally working on the functional tests, but whenever they need the load test, they're not spending extra money and extra time on creating the load test scenario, but they're just scaling up that functional test scenario. It might be a bit more expensive than creating a dedicated load test scenario and running the load test, but it's definitely faster, and it might make sense to pay extra for the load testing tool to save on the development time. Yeah, and actually that's pretty much it that I wanted to tell you. I'm not sure if I see any questions.